Number 16, given the sketch of f prime, sketch a possible graph of f. All right, so to do this, I'm going to make myself an f prime chart. And f prime to f prime, they're on the same level, so I'm going to be looking above and below the x-axis. Okay, so first of all, f prime hits the x-axis at -2, 0, and 2. Before you get to -2, the graph is below the x-axis, and then above, and then below, and then above. So what this is telling us about the function is the function must be decreasing, and then increasing, and then decreasing, and then increasing. Okay, so if we go to draw the graph of f, I don't know what's happening at -2, so I'm just going to make it up. I'm just going to put a point there. It doesn't really matter. Okay, I need to decrease till I get to -2. Okay, and then I need to increase till I get to 0, so I can be anywhere here. And then I need to decrease till I get to 2. And then I need to increase after that. Okay, so you could have your points anywhere you wanted, but it should have somewhat that same shape, the same ups and downs that I do. Okay, number 17 and 18, let f be a function defined on the closed interval -3 to 4. The graph of f prime, the derivative of f, consists of one line segment and a semicircle as shown below. On what intervals is f increasing? And then it asks for points of inflection. So I'm going to start by making an f prime chart and an f double prime chart. Okay, so f prime, this is f prime. We're going to make an f prime chart, so we're going to look above and below. So it's going to be above the x-axis till I get to -2, and then it's below the x-axis all the way until I get to 2, and then it stays below the x-axis. All right, for f double prime, going from f prime to f double prime, I'm going down a level, so I'm going to be looking at the slopes. So the slopes of this graph are going down, or they're negative till I get to 0, and then they're positive till I get to 2, and then they are negative after that. So now once I've done that, we don't even have to look at the picture anymore because now we're ready to answer information. Okay, so on number 17 it says on what intervals, if any, is f increasing. We're going to look at f prime where f prime is positive, which will be right there. It's not negative infinity to -2. We have to look where the interval starts, was at -3. So it's going to be -3 to -2, and that will be because f prime is positive. Okay, then for part number 18, x coordinates of points of inflection. If f double prime changes signs, then we have points of inflection. So that will be at both x equals 0 and at x equals 2. And that will be because f double prime changes sign. Okay, number 19. Sketch a graph of a function having the indicated characteristics. Remember on these ones, they basically are just giving you information to help you fill in your f prime and f double prime chart. And you can probably hear my son having cereal and scraping his bowl. Nice. Okay. So we're going to here, f of -1 is equal to 0. And so that just means the point -1, 0 exists on the graph. Okay, the next part is my f prime chart. All of these parts right here are f prime chart. Okay, it tells us that f prime of -1 is undefined, so that is a critical number. This is also going to tell us that there's got to be a sharp turn there probably. Okay, f prime of 2 is also equal to 0, so that's another critical number. And then it tells us the derivative is negative before we get to -1. It's positive between -1 and 1, and I think actually that's supposed to state 2. It's positive between -1 and 2 and also after 2. Okay, and then the second derivative, I notice things are happening before 1 and after 1, so that must be a critical value. The second derivative is negative till I get to 1, and then it's positive after 1. Okay, so what this is talking about, my graph is going to decrease and then increase some more. And here we're going to be concave down like a frown, and then concave up like a cup. Okay, so here we go. We need to decrease till we get to -1, but I need to be concave down. I'm going to keep concave down here. Okay, and then it's going to increase till I get to 2, but I'm going to be continue to be concave down till I get to 1. So it's going to look something like that. And then at 1, actually that's when it's going to change concavity. I'm wondering, that must be it. This is really not quite right. because we're supposed to increase. I think this is supposed to be a 2 also, otherwise the graph will not work. So we're just going to fudge it here a little bit. So we're going to go all the way to 2, and then we're going to switch concavity and keep going positive. So it's going to look something like that. The biggest thing that we want to, we're concave down till I get to 2, and then again concave up, and there is a sharp turn, notice, at -1, so that should work out okay. I might have, if you looked at my solutions, I might have changed those to 1s, but just something was misworded on that one. Okay, 20, pictured as a graph of f prime of x for what values of x is a graph of x concave up. We need f double prime, so here we go. F double prime, if this is f prime, we're going down a level, so we're going to be looking at the slopes. So if I'm looking at the slopes on this one, my slopes are going down until I get to -4, and then they're going up till I get to 0, and then they're going down till I get to 4, and then going back up again. So if I'm looking for where's the graph concave up, that would be where f double prime is positive, so that would be from -4 to 0, and then from 4 to infinity, and that will be because f double prime is positive. Oh, nice. Okay, and then number 21, find the antiderivative of the function f of x equals 3/2 x squared passing through the point 1, 2. So antiderivative means we're trying to find a function, and I'm going to call it big F, so that when I take the derivative of it, I will get this. So first thing I know is if this is x squared, it's going to have to be x cubed, so that when I take the derivative of it, with the power goes down 1. So I need to figure out what should I put down here so that when I take the derivative of it, I'll get 3/2 x squared. I already know I'm going to bump the 3 down, so the 3 is already going to be there, but I don't have the 2. So if I put 1/2 right here, notice when I take the derivative of that, I would get 3/2 x squared. So that works, but then I do also have to put plus a constant, because we could put anything there. And then I want my antiderivative to pass through the point 1, 2. So we're just going to plug in, that would be our x and y. So we're going to get 2 equals 1/2 times 1 cubed plus c. So I'll get 2 equals 1/2 plus c. So then I'll subtract 1/2 from both sides, and 4/2 minus 1/2 would be either 1.5 or 3/2. So c will equal 3/2. So my function, or my antiderivative, would be 1/2 x cubed plus 3/2.